Okay. Okay, so we got 2 people here, so 3 people. So hopefully a few more people start showing up. We'll get started. Well, I mean, class doesn't technically start until what, 10 or something like that. So we'll give people a few more minutes to show up. I just posted the link to the stream on our website now. If you are watching from the website, I encourage you to click on the YouTube button. So if you go to the website here, and like let's say you're just watching it like all from here, I encourage you to press that YouTube button to watch it in YouTube. This isn't technically. So wow, how meta is this? We're looking at YouTube through YouTube, live streamed on YouTube. Oh, there's Liel. Okay, so I am going to make myself a cup of coffee, and when I get back, hopefully we'll have more than 4 people, and we will get started. You can say hi to my cat. She's going to hang out with you while I make a coffee. This is Goose. You might recognize her from my little avatar. Still only 3 people. Oh, man. Okay, so I know that a lot of us... look, she stayed the whole time. She's such a good cat. I know that some of the students in our class have English right now. So I still have to figure something out about that. Let's see what we're going to do. Oh. Okay. So I'm guessing that this is just Dahlia, Julia, and Liel. Hi, guys. So, what are we going to do? Oh, and I'm not sure who that is. Okay. So we'll just wait a few more minutes. Hopefully, a few more people will waltz on in. Let's just sit tight and hang out until, let's say we'll have a minimum of 5 people. But in any case, yeah, we'll just hold tight until then. Okay. Oh, it's Siri. Okay. How have you guys been doing over this strange time? Any cool stories about your quarantine experience? By the way, there's a good 10 or 15-second delay between what I say and by the time you hear it. So, hey, we got 4 people. All right, I'm getting there. Oh, back down to 3 people. Oh, how old is my cat? That cat, I have 2 cats. Goose she's gosh, I should know. I think she's 2. And then our older cat, I think she's about maybe 4 years old. I'll show you my other cat. This is Kima. She's very sweet too. She's a little bit grumpy because I just woke up from her nap. Say hi, Kima. Okay, we still only have 4 people. Got cat hair in my mouth now. Okay. Okay, you know what? Let's just get started. So, oh, there's 5 people. I wanted a minimum 5 people. There's Mark. Okay, awesome. Hi, Mark. So if you have any contacts with your friends, oh, so English class right now. Okay, so we're gonna hold up. Okay, so yeah, we'll hold up a little bit. I assume there's a few other people in English class right now. So yeah, I mean, just keep in mind all the teachers we're all kind of just learning this as we go. So there's going to be a few conflicts. So I'll do my best to sort of reach out to other teachers and just tell them when I'm streaming so that we can all kind of work together here. So we'll wait for Mark and whoever else is in the English class to get started then. Yeah, no problem. In the meantime, I'll start writing some questions down, and then that way we don't have to waste time. So we wanted to look at some of the Friday math problems. Sure thing. So I'm going to go to our website. Grade 10s. Okay, March 20th homework. And I think that someone else was asking about March 18th homework as well. The graphing questions. Okay, yeah, sorry, I'm getting a little distracted here with my email. What am I doing here? Oh, yeah. Just looking for an email a student sent me. There it is. Question. The March 18th homework. Yeah, so we'll do some of the March 18th homework, some of the March 20th homework. We'll kind of do a bit of a review session for both. And, yeah, we'll take it from there. So how many people do this? Oh, I got 6 people here. This is good. Okay. Not for today. Factoring with fractions. Yeah, that's okay. Okay, good. Okay, so it looks like you're about to finish. I'm gonna start writing some questions down, and then we'll take it from there. Okay, so this one was March. Let's do the March 18th one first. We'll go chronologically. So I think that we were asked to do some graphing, and I think that that's where this one student was asking me to help out. So let's. What I'll do is I'll do some similar questions. I'm not going to do exactly the same ones. So let's open this, grade 10. Grade 10 advanced, quadratics. My computer's really glitching out right now. I don't know what's going on. Okay, I can't seem to. Uh-oh. Is the stream okay? Because my computer is like really glitching out. pretty hard here. Seems like it's okay. Okay, anyway, I'll just do some of the same questions that were on the worksheet. So I'll go into here, and I will do the March 18th quadratic homework, and we'll just do them together. Okay, so we're going to sketch the graph of each function. We're going to say the x and y intercepts, domain, range of each quadratic function. If there are no x-intercepts, then state that. So keep in mind a couple of things on the worksheet I was unable to put in the solution. So I'll go over the solutions with you. So number 21 and 22, I'm hoping we're fairly straightforward. I'll quickly do those ones. Take a quick screenshot, do this, oops, do this, like that. This will be good. And I will go done, save to photos, go back over here, start a new page, and I'll just paste this in here like so. Bada boom, bada bang. Look at that, easy as that. Beautiful. Too big. Okay, so y equals x squared. So this one is fairly straightforward. We go over 1, up 1, over 2, up 4, like this. So this one is quite straightforward. There's really not a whole lot to do. I'm hoping that this one wasn't the cause of too much concern. Okay, yeah, it looks like the chat is going. So I'm going to do my very best to keep up with the chat. Obviously, I'm going to be distracted with what's going on my iPad, but we'll do what we can. Kitty 127. Huh. I don't know what that means. What I do Windows my slat? What? Okay, I don't understand what you guys are talking about. Okay, so let's just stick with this then. Okay, so the vertex, this is at the point 0, 0, right? That's this point right here. That's the vertex. What was I asked to state? So I want the x and y intercepts, the domain, the range, and that's it. Okay, so I'm just looking for the x and y intercepts, the domain, and the range. Okay, so x-intercepts. X-intercept is 0, 0, right? It's that point right there. And same with the y-intercept. The y-intercept is also that point 0, 0. Okay. The domain. The domain, well, there is no restriction on a quadratic function when it comes to the domain. So the domain is a set of all real numbers. There's nothing that we can't equal. Okay. Okay. Just keeping my my eye on the chat. Okay, and the range. The range, those are all the possible y values that I can get. So you'll notice that there's nothing in the negatives over here. So all of my y values are positive or at least equal to 0. So the range, so we start at 0 and then we go off to infinity, positive infinity, but we don't include it. So I use a round set of brackets. Okay. Okay, this one here, I've got y equals x minus 2 squared plus 4. So that means that the vertex is at the point 2, 4. So I'll go over 2 and then up 4. And I'm still pointing up, so I go over 1, up 1, over 2, up 1, 2, 3, 4. And my quadratic function looks something like this. Okay, and keep in mind that we actually, I'm gonna do this a little bit better. We want to see like it's a nice flatness. right here. Even that's not that nice. So some nice flatness. So right at the bottom of this graph, it should be nice and flat. Don't make it pointy because it's not pointy. And that looks a little bit better. Okay, so that's what our graph looks like. All right, we got 8 people. I'm feeling good about this. Okay, so that's what our graph looks like. Now I want to write the x-intercepts, the y-intercepts, the domain, and the range. Okay, so x-intercepts, there are none. This graph never crosses the x-axis. So like if a graph looked like this, then these would be our x-intercepts. But in this case, we have no x-intercepts. So we have none. Our y-intercepts, well, that would be this point right here. So that would be the point 0, 8. If you wanted to figure that out without actually graphing it, what you would do is you would just set x equal to 0. So you would say y is equal to 0 minus 2 squared plus 4. And that's equal to, well, 0 minus 2 is negative 2 squared plus 4. And that's equal to 4 plus 4, which is 8. That's where this 8 comes from. Okay, the domain and the range. So again, the domain is going to be the set of real numbers. That's going to be the case for all of these quadratic functions. And the range, well, it looks like we're not going to have any values below the line y equals 4. So all of our y values are going to be greater than or equal to 4. So I'm just going to write this in interval notations. I've got positive 4 going up to positive infinity. And remember, we always use a round bracket when we are using infinity in our interval notation, right? Because we don't actually include infinity. It would be impossible. There's no point on this that, like, you could never graph the point infinity. You would need a piece of paper that is infinitely long, which doesn't exist, right? So we don't actually include the point infinity, but the whole point of writing infinity is saying that there is no limit, right? There's no highest value. Okay, any questions about these ones? Or I'm hoping that these ones were kind of the more straightforward ones that didn't cause too much concern. Let's try some of the more challenging ones. So I'm going to skip 23 and 24 because they're pretty much the same as 22. Let's do 25 and 26. Yeah, let's do these ones. I think these ones are probably the ones that are causing issues if you're having issues. So I'll do this and I'll do this. Okay, there we go. And I will save the photos, go back here and include it right there. Here we are. Okay. The next page was confusing. Does that include this one? I'm gonna I think it's better if I just type in the chat because there's such a delay between me writing and me talking. I think so, right? Yeah, 25 and 26. That's the next page. Okay. Yes. Okay. Awesome. So let's do this. Okay. So there's a couple things we need to do first. So here, if we're going to graph this, we need to have this in vertex form. Okay, so we're going to convert this into vertex form. In order to do that, we need to complete the square. So to complete the square, the first thing I'm going to do is I'm going to factor out a -2. So I'm going to write that this is equal to -2 times x squared plus 2x plus 5 over 2. Okay, so I factored out my -2. Okay, so I'm hoping that you can see that I haven't actually really changed anything about the expression. I've just factored out a -2. Still the same thing. I've just done some factoring. Now I'm going to complete the square. So what that looks like is the following. I'm going to say that this is equal to negative 2 times, and I'm going to sort of complete the square for this portion here. So I've got x squared plus 2x, and when I complete the square, I take this middle term, and I do 2 divided by 2, and I square it, which is, well, 1 squared, which is 1. So I add 1, and I minus 1, and then I write whatever is left. So again, I haven't changed the quadratic expression yet. I've factored out a 2, and then inside the brackets I've added 1 and subtracted 1. It's the same thing. It just looks a little bit different. Okay, let's carry on. So I've got negative 2 times, well, this portion right here, this is now a perfect square. This right here is x plus 1 squared. If you don't believe me, and I'm talking about this portion right here. So if you don't believe me, x plus 1 squared, that's equal to x plus 1 times x plus 1, which is equal to x squared plus x plus 1, which is equal to x squared plus 2x plus 1. It's the same thing. It's exactly the same thing. Okay. Mr. Bennett, what would we do if the year got canceled? I don't know. The school year, yeah. Mr. B, does it matter which order you add 1 or subtract 1? Yes, it does matter. You want to add before you subtract in this case. Because this term right over here is always going to be positive. So I want the positive term right here, and I want, let me just use this. So I want the positive term here, and then I want it followed by the negative term. So when you're completing the square, oh, you can see my cats fighting in the background. Check it out. Oh, they're so awesome. Sorry, it's hard to work from home. It's so easy to get distracted by all these cool things. Yeah, so anyways, we want the positive term followed by the negative term. So you want the positive term in the brackets. Yes. Okay, so going back to here, so I've completed the square here. So this portion is this in blue, and this red part. So maybe what I'll do is I'll try to color code all of this. So this is all in blue, plus 1, and then everything in red. Well, negative 1 plus 5 over 2, well, that's going to be 3 over 2, right? Because negative 1 is negative 2 over 2, so negative 2 over 2 plus 5 over 2 is 3 over 2. And now I've closed this all off. Okay. So now this is starting to look a little bit more like here. Positive term in the brackets. Very nice. Yeah, okay. Sorry, just keeping my eye on the chat. Okay, so so now what I want to do is now I want to distribute this negative 2 throughout the brackets. Okay, so this is now equal to negative 2 times x plus 1 squared plus, well, actually it's going to be minus because it's a negative 2. I'm going to have minus, well, 3 halves times 2 is just 3. So we've got negative 2 times x plus 1 squared minus 3. Now, if you don't believe me that these are the same thing, let's just, as a little side note, let's expand this. So this is actually equal to negative 2 times x plus 1 times x plus 1 minus 3. This is equal to negative 2 times x squared plus 2x plus 1 minus 3. This is equal to negative 2x squared minus 4x minus 2 minus 3. And that's equal to negative 2x squared minus 4x minus 5, right? And that's our initial thing. So this is definitely equal to this. right? So all we did was we just changed what it looks like, but the actual value is exactly the same. So now that I've got this in vertex form, I can graph it. So I'm gonna graph it now. So I've got the point -1 and -3. So it's going to be right here. The stretch is going to be -2. So it's going over 1 and down 2. Over 2, and then instead of going down 4, I'm going down 8. So we got 1, 2, 3, 4, 5, 6, 7, 8. And over here as well. And I'll zoom in just to make sure I get a nice flat sort of arch here like this. Beautiful. Okay. And this is going to go down like that. And look at that. Okay. So that's what my graph looks like. So I've graphed it. Great. Now I want to write the domain. It's a set of all real numbers. The range, well, there's nothing that's going to be above -3. So the range is going to be, well, the largest value is -3, and we include -3, but we start at -infinity. So in interval notation, it's going to be from -infinity all the way to -3, including -3. The x-intercepts, well, this is our x-axis. There's nothing that crosses the x-axis, so the x-intercepts, there are none. And the y, I'm just going to erase this. The y-intercepts, looks like we have one at -5. Let's verify that. So I'm going to set, to find the x-intercepts, you set x equal to 0 and solve for y. Okay, so set x equal to 0. So I'm going to just do it right over here. So I've got y equals -2 times 0 minus 4 times 0 minus 5. Well, -2 times 0 is 0. -4 times 0 is 0. So this is, all that's left is this -5. Indeed, our y-intercept is -5. And there's only ever going to be one y-intercept. You don't have to worry about there being two. And I believe that's all I was asked to do. To graph it, state the domain and the range, and the x-intercepts and the y-intercepts. So there's that one. I wonder if I should be doing any other ones, because the other ones are pretty much, it's the same process. And I don't want to do all of them, because then you wouldn't get the practice. So I'm gonna leave it at that, and then I'm gonna do some of the March 20th homework, because we're actually, believe it or not, we're kind of running out of time, even though I've really only done like 2 examples. Okay, so let's do one from March 20th. Were there any in particular that we wanted to do? The first one, okay. Okay, so, oh, that's a grade 9 one. Grade 10, solving quadratics by completing the square. Okay, so I'm just gonna copy them down. I'm not gonna take a screenshot. Let's see here. Let's do, okay, I'll start off with the first one. Why don't I do like the first one, the 7th one, and then see what happens from there. Maybe we'll do like one of the later ones. Okay, so the first one, so I've got x squared, okay, I'll write this down too. So this is March 20th homework number 1. Okay, so I've got x squared x squared plus 9x, x squared plus 9x minus 3 equals 0. Okay, so it's probably gonna be pretty hard to find two factors of -3 whose sum is positive 9. So what we're gonna do is we're gonna complete the square, right? Because this is gonna be too hard to factor, right? So I'll complete the square. So this is gonna be x squared plus 9x. Now I'm gonna take this 9, I'm gonna divide it by 2, and then I'm gonna square it. So that's gonna give me 81 over 4. So I'm gonna add 81 over 4, and then I'm gonna subtract 81 over 4, and then I'm gonna subtract 3. And just to make things very clear, I'm going to color code this. So this next section is going to be, let's make that, how about pink? And this one, I guess it could stay one color, but I'll make it blue. So this will be blue. So I don't like that blue. Color, come on, color. Yeah, that's a better blue. Okay, so let's start off with the blue stuff. So this is what I'm going to write as a perfect square. So this right here is going to be x plus 9 over 2 squared. Where did the 9 over 2 come from? It came from this. So this is what goes right there. Okay. Now, if you don't believe me that this blue stuff is all the same, well, let's try it out. Let's do x plus 9 over 2 squared. That's equal to x plus 9 over 2 times x plus 9 over 2. And that's equal to x squared plus 9 over 2x plus 9 over 2x plus 81 over 4. And that, of course, is x squared plus 9x plus 81 over 4, which is what is in blue. So, so far so good. Oh, it looks like we have some eureka moments happening in the chat. Okay. Now let's take care of the pink. And so I've got 81 over 4, or negative 81 over 4 minus 3. So this minus 3, let's put that over denominator of 4. So I've got negative 81 over 4 minus 12 over 4. All right, that's what 3 is. And just on this next line, I'll just get it over with. So 81 plus 12, that is 93. So I've got negative 93 over 4. And on the left here, I still have x plus 9 over 2 squared. Okay, and I've forgotten one thing here. It's important to remember that this is actually an equation, right? We have this equals 0. So let's make sure that we're still writing equals 0 at every stage. Okay. Sorry, I should have been writing that at every point of this equation, because we're trying to solve for x here. That's our goal here. Is we're trying to solve for x. So now I'm going to bring the pink stuff to the other side, and I'm going to get positive 93 over 4, and that's equal to still x plus 9 over 2 squared. Okay. So now I'm going to take the square root of both sides. But when I take the square root of both sides, I have to introduce this plus and minus symbol, because it's possible that what's inside these brackets here could be negative, and when we square it, we actually cancel that negative out. So we do have to be aware that when we introduce our own square roots, we have to write a plus and minus sign. Okay, so that gives us x plus 9 over 2 equals plus or minus the square root of 93 over 4. Okay, and we're almost done here. So now we can solve for x by just saying that x is equal to, I'm going to stop with the color coding now. So x is equal to negative 9 over 2 plus or minus the square root of 93 over 4. Now I want to simplify this as much as I can. So the square root of 93 over 4, that's equal to the square root of 93 over the square root of 4. And the square root of 4 is just 2. So this is the square root of 93 all over 2. So this is equal to negative 9 over 2 plus or minus the square root of 93 all over 2. And this is equal to negative 9 plus or minus the square root of 93 all over 2. And that's what x is equal to. So x has two solutions. We've got negative 9 plus or minus, or plus the square root of 93 divided by 2. And the other one is negative 9 minus the square root of 93 all divided by 2. I'm going to leave it to you to punch that into your calculator to get an answer. Okay, let's do a couple more questions. Let's try, what did I say? 13? Do you want to do 13? Let's do 13. I'll give you a second to finish writing that down if you're following along. Okay, let's do number 13 now. Keep in mind this is all going to be posted on YouTube afterwards, so if you would like, you can log into YouTube and pause the video if you're wanting to continue writing stuff down. Okay, so let's do number 13 of the same worksheet. So that is negative 2x squared plus 5x plus 7 equals negative 3x squared minus 3x. Okay. So the first thing that we want to do is we want to set this whole thing equal to 0. So I want to put all of this stuff over on this side. That way I can set the whole equation equal to 0. Okay. So this is going to look something like, well, if I add 3x to both sides, then I'm going to get just x squared. And if I add 3x to both sides, I'm going to have 8x. And then I've got plus 7 equals 0. Okay, and this actually looks like it's very easy to factor. So if I wanted to, I could just factor this out. In fact, why don't we just factor this one? Because it's going to be much easier to factor. So if you can ever factor a function, a quadratic equation to solve it, then do that, because it's going to be a lot less work than completing the square. Completing the square takes a lot of time. So I'm going to say that this is x plus 7 times x plus 1. That's all equal to 0. In which case, one of these has to be equal to 0. So either x plus 7 equals 0 or x plus 1 equals 0. So the two solutions for this one is x equals negative 7 or x equals negative 1. So that one's not too bad. Okay, let's try another one then. Let's see if we can do one that's a little more complicated. Let's do 14. I think that 14 is going to be a little more complicated. And I'll take some requests too. Like if there was one in particular that you were stuck on, then let me know and we'll work on that one. So we'll do negative 8n squared minus 8n equals 37 minus 10n squared. Okay. Okay, so just like last time, we want to make sure that everything is on this side. So we're going to, in this case, let's start off with the 10n squared. I'm going to add 10n squared, which will give me 2n squared on the left. And then I've got minus 8n, and then I'll subtract 37 from both sides to get negative 37, and that's all equal to 0. Next up, I'm going to factor out a 2. So I'm going to say that this is 2 times. Now I'm going to go back to my color coding scheme. So I'm going to have, in pink, the stuff I'm going to complete the square with. So I've got n squared minus 4n, and everything else I've got minus 37 over 2. I can't, that's an odd number, so I can't factor it. And that's still all equal to 0. Okay, now here's a nice little trick. This is like actually quite a nice trick, which will save us a fair amount of time and effort. Right off the hop, what I'm going to do, notice that this is all equal to 0. So I'm going to multiply both sides of this equation by 1/2. So I'll write that this is 1/2 times, and I'm going to multiply this by 1/2. Okay, so the 1/2 times 2, that cancels out, that's just equal to 1. And 0 times 1/2, that's also equal to 0. So over here I've got 0, and here now I've pretty much eliminated that 2. So now all I've got left is n squared minus 4n minus 37 over 2. And that's just going to make everything look a little bit nicer. Okay, so now let's complete the square. So I'll do that in pink. So I've got negative 4 over 2. I'm going to square that. That is going to be negative 2 squared, which is positive 4. So I'm going to add and subtract 4. So I've got n squared minus 4n plus 4 minus 4 minus 37 over 2. And that's all equal to 0. Okay, so in pink, I've got, well, this is going to be n minus 2 squared. And then in blue, well, that's going to be minus 8 over 2 minus 37 over 2. I'll write that one more time. So that's n minus 2 squared. And negative 8 minus 37 is negative 45 all over 2. And let's actually turn that into minus. There we go, that looks better. And I've been forgetting to write my equals 0. This is all equal to 0. And now I'm just going to bring the 45 over 2 to the other side. So now this is all equal to 45 over 2. And I've got n minus 2 squared is equal to that. And now I think it's fair to stop with the color coding, because it's getting a little bit annoying. You can go all over to green. So now I'm going to take the square root of both sides, and when I do that, I have to include the plus or minus symbol. And I'm going to be left with n minus 2 equals plus or minus the square root 45 over 2. Okay, and now I'm going to say that n is equal to plus or minus, 2, I'm bringing this 2 to the other side, plus or minus the square root of 45 over 2. And we cannot simplify that anymore. I mean, I suppose you could factor out a 9 from the 45, but we don't have to do that. So there you have it. That's that question. So the gist of these is that we're just, we set the whole thing equal to 0, and then we complete the square. The way we complete the square is by taking this middle term, dividing it by 2, and then squaring that, and that's what we add and subtract. And then when we actually find the what's in the inside the brackets, this minus 2 is what's inside these brackets. So that's how completing the square works. So the chat has been pretty quiet. I'm wondering if maybe you're writing some of the stuff down, or maybe we're just kind of doing okay with this. I'd planned to talk about a really famous formula that you guys are going to be using a lot of in your mathematical careers, called the Quadratic Formula. But I think it's probably best to leave that for tomorrow, because it actually takes a fair amount of time to go over. So we're gonna leave it at that. Yeah, if unless you have any other requests that you can think of, then put them in the chat right now, and I'll quickly do it. So yeah, let me know if you have any questions. Don't hesitate to email me or send me an Instagram message or anything like that. Oh yeah, so okay, so we've got one more question. So could you go over how you got the -4/2 squared again? Okay, yeah, let's quickly go over how we're completing the square here. Oops. Yeah, okay. Okay, so if I want to complete the square, so let's just take a look at what a perfect square looks like. So if I have a perfect square, it's going to look something like this, like x plus, I don't know, let's do x plus 7 squared. Well, x plus 7 squared is going to be x plus 7 times x plus 7, and that's equal to, well, x squared plus 7x plus 7x plus 49. Or in other words, it's equal to x squared plus 2 times 7x plus 49. Okay? So really what we're doing here is we're looking for what is that number? So in other words, like what's this number? So these two numbers are the same. So this middle term here is going to be double what this guy is in here. So if I were to ask you to complete the square, and let's use this as an example. So we'll do x squared plus 14x plus 49. This is a plus, by the way. It looks like a minus. It's a plus. Excuse me. So if I was to ask you to complete this square, what I'm going to do is I need to find out what this guy is right here. Oh, sorry, and I don't want this 49. So if I want to complete the square of x squared plus 14x, well, we're going to have to add some stuff and subtract some stuff to make it a perfect square. So, come on. There we go. So what I'm going to do is I'm going to take this and I'm going to divide it by 2. So I've got 14 divided by 2, and then I'm going to square it. And that's going to be, well, 14 divided by 2 is 7 squared, which is 49. And that's where this number comes from. So what I'm going to do is I'm going to add 49 and subtract 49. And then now this, right here, this is a perfect square. Okay. Just catching up with the chat. It's just what you do with the question, yeah. Okay, so I'll just continue on. It seems like you guys are understanding it, but I'll keep going. So now I'm going to write this as something x plus something squared. Well, that something is whatever is inside these brackets here. So 14 over 2 is 7. So this is x plus 7 squared. But then I also have to write this minus 49 because I had to add 49 here, which means that I have to subtract it. Otherwise, I would be talking about something completely different. So yeah, what we're going to do, I guess we'll kind of end it there. So I've been streaming for about an hour now. So I'm not going to post any new homework, but hopefully if you were kind of stuck over the weekend and you weren't able to complete some of the questions, hopefully this helped. And hopefully you can finish off that homework. If you do have any sort of discrepancies or any kind of questions about any more questions that you couldn't finish, definitely write them down, send me an Instagram message or an email or what have you, and we'll tackle them tomorrow. Otherwise, tomorrow we'll take a look at the quadratic formula, and it's a really useful formula. Basically what it does is it eliminates our need for completing the square, because it's basically just a formula that does all the completing the square for you. So on the one hand, completing the square is nice because you don't have to memorize anything. You just do a process, and as long as you understand how the process works, it'll work every time. But the quadratic formula, it's something that ideally you would memorize. One of the few things in math that you do need to memorize. So yeah, I mean, you compare it to other classes, and in other classes, you know, there's stuff you have to memorize, and you know, math is no exception. But usually in math, there's a lot less you need to memorize. But the quadratic formula is definitely one of those things you need to memorize. You know, I learned it about I guess over 20 years ago, and I still remember it. It's one of those things that you just have to memorize. So we'll look at what the formula is tomorrow. I will derive it for you. I might see if we can try to do something a little more interactive, where I get you to try to derive it. But in any case, that's what we're going to do tomorrow, and then tomorrow I'll post some new homework. Yeah, unless there's other questions in the chat, I'm gonna end the stream, and I'll post it on the grade 10 webpage. Yeah, I'll see you next time. I'm just gonna leave the video on for a little bit. I think I've mentioned this a couple times, but there is a considerable delay. So I'm saying this now. You guys won't hear me until about 20 seconds later. So I'll give you a chance to ask a question if you have it. Otherwise, I will sign out. Do I like pancakes? Yes, I love pancakes. I think I like waffles a little bit better. Waffles with, what do you call it? Whipped cream and strawberries and maple syrup. That's probably my favorite breakfast. Okay, so I will see you tomorrow. Bye-bye.